So what are you guys?
We're the Smartwood family.
So what I want to talk about in this video is complexifying the integral, okay, or just complexifying in general. So what's the point? The point is sometimes you have a problem here that sits with the real numbers, okay? And it turns out that if you complexify it, turn it into a complex number more or less, especially, since you can use this sort of stuff, like this guy, guys that look like this. You can do things like differentiate, integrate, all of that's a piece of cake. And then what you can do is bring it back down, right, to get the component you want, okay? We actually translate back to the real case. It actually makes a lot of problems much easier sometimes than doing it the direct way, okay? All right, so what's an example of that? We can do some real applications, and if you're interested, we will, especially in physics. But first, let's just do one with integration. So super mellow integration problem, okay? Okay, so here's one problem we could do. So how would you do this without? Well, one way is you could do integration by parts. Then you find out you have to run it again, because there'd be like a cosine guy in there. Then you run it a second time, and you see that sign pop up again with opposite sign. Then you would bring it all the way over, and now have 2 of the original guy equal to some crud. You divide out by 2, and you finally get your answer. Okay, that's fine, but that's kind of tedious and cumbersome. We want to show is the actual integration can be made way simpler if we go to complex numbers. Okay, so if you remember in polar form, this complex number can be represented as e to the I theta, okay? Obviously here, the parallel we want to do is, instead of theta, we're just going to change the dummy variable and turn it into this, right? Okay, but again, if you look at the setup, I don't only see sine and cosine, I just see sine, right? So what I really care about is this guy, okay? So there's going to be an I in front, but do you agree here's like the real component, and here's the imaginary component? The component itself is real, then we tack on the I and it becomes imaginary. So what I want to do is focus on that imaginary component. Okay? To take advantage of this, let's complexify. Let's turn this problem into a problem that looks like this. We're going to instead compute this integral. The problem with this integral is it not only carries information we want, it carries extra junk as well. But in the end, when we're done, we're just going to clean it up and pull out the piece we need, and then we'll be in good shape. Okay? So let's try this. So let's first rewrite this. Okay, so then we just combine these guys, which if we just factor out, we're going to get this thing. Okay, so if you're comfortable with this, now you see why we've moved to the complex form, right? Because look at how easy this guy is to integrate. If I want to integrate this guy, we'll just get something that looks like this. To integrate this exponential, all we're going to do is copy the guy, right? And then take the derivative of this thing here, right? So that's going to be this, -1 plus I, right? We're going to divide by the derivative, and we're done. This is actually the answer, okay? It's not the form that you typically recognize or see in calc books, but that is the right answer. So now, what's our job? We need to translate back, okay? Well, let me correct myself. It's more than the right answer, right? Because what we wanted was not the whole thing, but this component. So let's go for that. Okay, first we want to translate back. That is 1 over -1 plus I times e to the, I'm going to go ahead and redistribute, -x plus ix. Okay, so we want to work with this guy. And we want to rewrite him so you can see the real and the imaginary components. So maybe first this. Let's work on this guy. I think I'm going to multiply top and bottom by the complex conjugate, which in this case would be -1 minus I, multiply this on bottom and up top. -1 minus I up top, right? The top is going to become -1 minus I up top. Bottom, you're going to get a squared plus b squared, where b happens to be 1 here. So that's going to be 2. Then you're going to e to the -1 plus I, right? So that's something like this. Okay. The reason why I want to do this is clearly real, so I can pull these components apart. Okay? Okay, so now we're going to get -1 I over 2 times e to -x. Okay, times this guy. But this guy we know is what? Cosine of x plus I sine of x. Okay, so what we want to do in theory is multiply everything out and then look for the guys that make up the imaginary component. But we can take a shortcut here. I think we want to go ahead and bring out this guy and this guy, because they're just going to maybe be a factor for everybody, right? So e to negative x over 2. Okay. Second, do you agree that we want imaginary guys? So negative 1 times cosine of x, no good. Negative 1 times I sine of x, good. So we're going to put that in there. Negative I sine of x. Okay? So negative 1's done. Negative I times cosine of x, it's good. Negative I times I sine of x, well the two i's will become negative 1, so no good. So the only term we care about now is this guy and this guy. That's going to be minus I cosine x. We didn't even bother to compute the real component because we don't care about it. So now what we're looking at is, if we're right, this should be the imaginary component, right? So again, we put that I in there so we can complexify it. So we want the component really, just this part. So we can ignore this thing. Somebody agree? And now we have what we want. So it's going to be e to negative x over 2 times negative sine negative cosine. Okay. But really just to clean it up, let's just go ahead and bring this all out. So e to negative x over 2, bring that negative 1 out. Okay? And what's left over? Sine plus cosine. Okay. The point was, if you complexify, you make things easier. Okay? I know in this particular problem, the integration was definitely easy. You might have thought this was a pain, but there are other cases where you'll get so used to this, that'll be a piece of cake. And then the other stuff you would have had to done would have been so painful that complex.